So not only do we want to know which amino acids are within a peptide, but we'd also like to be able to create our own artificial peptides. And so let's think about this reaction. On one end of the amino acid, we've got the carboxylic acid. On the other end, we've got our amine. And then we want them to join together to form an amide or a peptide bond. However, if we think about organic chemistry, this is not going to occur, right? We have an acidic proton. We've got our amine, which is a relatively good base. And so what's going to happen here instead is an acid-base reaction, which will then leave us with an O minus, and that's not a good leaving group. And so without that good leaving group, you cannot form this amide. And so overall, this reaction will not just happen by itself. In your body, you have enzymes that do this. In the chemical laboratory, we can use DCC, that stands for dicyclohexyl carbodiimide. Quite a mouthful. Let's take a look at what the structure looks like. So we've got our cyclohexane on either end, and then we've got two of these components. And basically what this does is it attaches to the oxygen from the carboxylic acid and makes it a good leaving group. So we'll just say makes oxygen a good leaving group. And we've seen this type of motif before. So this is kind of the same idea as tosylation with alcohols, and as well with the oxidation of the alcohols. It's all just about adding some other group to that oxygen, which then turns it into a good leaving group, and then you can kick it out and add something in its place. In terms of the mechanism, go ahead, just check out the work along for how this works.